Okay, so we discussed all of this stuff in the last video, but we actually did not solve the problem. So let's go ahead and make sure that happens. All right. So again, this is section 3.4 and we're doing part 2. And so we learned all about y equals mx plus b and how beneficial it is and how it refers to certain types of lines. So here's the story. If I could basically find the slope and I can find the y-intercept, I have the line. So if I can get this number and this number, I have the equation of the line. So again, we're writing an equation of the line through these points in slope-intercept form. And so that's what we're going to do. So the first thing is we know how to find the slope given 2 points. We're going to utilize the rule that slope is equal to the change in y over the change in x, which we sometimes write as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's call this bad boy point 1 and this one point 2. And we're going to do what we need to do. We're going to subtract this guy and then subtract this guy and find the slope. So the numerator is 6 minus 6, and the denominator is 5 minus a minus 2. 6 minus 6 is 0. This bad boy is going to give me a positive 7. Minus minus gives me plus. So basically my slope is 0. Do you remember when we have a slope of 0? Hopefully you're thinking right back now that the slope of 0, you're looking at your nose, the slope of 0 is when we have this horizontal line. So we don't have a slope. What we need to figure out is what's the y-intercept. But as we think about this horizontal line, right, I want you to think about the fact that the points on this line are negative 2, 6 and positive 5, 6. What do you think the y-intercept will be? If the points on this line are negative 2, 6 and positive 5, 6, right? So hopefully negative 2, 6 is back here, positive 5, 6 is somewhere out here, and you're realizing what? That this has to be 6. And so the equation of this line is simply going to be y equals 6. Let's go back. The first thing we did is try to look for the slope. Since we didn't have a slope, since we had a slope, but the slope was 0, we recognized that we were looking at this type of line. We talked last time about this line and the fact that this line has an equation of y is equal to some term b. We needed to determine what the y-intercept was, what the b is, and clearly the b is going to be the y value for each of these points because there's a consistency of the y value across a horizontal line. All right, let's go ahead and check out the next example. Where here we'll be looking at writing an equation of a line. Let's read it out. Write an equation of a line in slope-intercept form. So we're still dealing with y equals mx plus b. And what we want it to be is perpendicular to this guy and containing this point. Perpendicular to this line and containing this point. What are the two things that we want? We want the slope and we want the y-intercept. Since we're talking about the slope, I want to figure out what it is. If it is perpendicular, do you guys remember the relationship between, let's get that out. Do you guys remember the relationship between lines and parallel lines and perpendicular lines? Hopefully you remember that parallel lines have the same slope. So if I had a over b, that would equal to a over b in terms of the slope of one line is a over b, the slope of the other line is a over b. They're just equal. But perpendicular lines, they have those types of lines. Perpendicular lines have slopes whose product is -1. So for instance, if I have a over b as the slope of one of my lines, the slope of the other one has to be b over a negative. When I taught this before, I would say that perpendicular lines have slopes that are opposite, change in sign, reciprocals, flip the fraction of one another, or product of equal to the -1, both we get the same thing. So I know you remember that. So now we're going to use that information to get through our problem. Let me shrink this away. Good, and let's make sure we can find the slope and the y-intercept. So the thing here is we need to we know that the slope of the line we're looking for is perpendicular to this one. So if we're looking at a slope that is y equals mx plus b is the form, this equation is -3x plus 2. So the slope is -3 over 1. This is not the slope of the line we're looking for. This is the slope of the line that it is perpendicular to. Therefore, the slope of the line we're looking for has to be the opposite reciprocal, or flip it and change the sign, or the number that's going to make the product of this and that number -1, kind of a mouthful, but the slope that we're looking for is going to be it's going to be positive 1/3. All right, because 1/3 times -3/1 is going to be -1. So I got 1/3 x plus b. I'm almost home, people. This is my equation almost. What's the next thing I need to find? Hopefully you're screaming at your computer screen, screaming. Please don't scream. Hopefully you're saying, yeah, B, come on, lady. And we're going to find the y-intercept, and we'll do that by using this point. How can we use this point? This isn't the y-intercept stuff, and it's madness. Well, you know that this is just one of the solutions to this equation. Where x is equal to 4, y has to be equal to 0. So what we're going to do is we're going to plug in those values and solve for b. Pretty slick, huh? So 1/3 4 plus b is going to give me 0, right? Because I plug in the 0 for y, since that's the y term, and plug in the 4 for x, since that's the x term. So 0 is equal to 4/3 plus b. Move this guy over to the other side, subtract 4/3 on both sides. Somebody's screaming right now saying, I hate fractions, but they're not so bad. They are our friends. So b is equal to -4/3. Guess what? We are done. We have found, that's not what I meant to do. We have found the y-intercept. We have found the slope, which we found just by recognizing that it had to be the opposite reciprocal of this guy. And so since we have all of our pieces together, we're going to do what we came to do. Y is equal to 1/3 x minus 4/3. Done. With this last equation, I want you to, I have the answer down here, so that's not really the concern. I want us to kind of think through a word problem that deals with linear equations and what are the signs that we're dealing with a linear equation. So let's take a look at this one together. Benito's current wireless plan, Plan X, costs him $39.95 per month for unlimited calls with 5 cents per text message. He is considering switching to Plan Y, which costs him $35 a month, a little bit cheaper, for unlimited calls, pretty awesome, but 10 cents per text message. Which plan offers the better rate? Well, the way that, what I want you to notice here is that there is an initial cost that you cannot, in both situations, that you cannot negotiate. If you make no calls, if you make no texts, and you are on this plan, you are going to pay that $39.95. Or if you're on the other plan, you'll pay the $35. So what I want you to see is that this is where the starting point is on each graph. This one is the $35 and this is the $39. And so when you are given a word problem where you are starting at a particular number, oftentimes that number is going to be your y-intercept. The next number that we want to talk about is something that is consistently changing over time. So here, the consistent, or the thing that is a variable that can change. And the thing that's going to change in this situation is going to be, in either plan, is going to be the amount of text messages that Benito makes, right? And so the cost, the final cost every month will be dependent on this changing thing. And so that is usually going to be your x-axis. That's going to be, and the rate of change is going to be your slope. So notice that this equation here, let me zoom in a little bit. Notice that this equation down here, this represents the two plans. This equation here and this one here have different slopes. The slope of this one is 0.5, which shows that even though you start off higher, the rate does not increase as much given the number of text messages. The slope is not as high, right, as this slope. This rate increases very, very much more rapidly. So these are the things that you want to kind of be able to identify when you're working with a problem like this. It appears that 100 text messages, it appears that for 100 text messages, the cost of the plan is the same at about $44. And so that's the intersection point where they both would give you the same, where you'd end up paying exactly the same amount of money. And the point of seeing this is sometimes we'll call this, depending on what we're comparing, we might call it a break-even point when two things come together and join, or it is the point where, as we have in this case, where you want to determine for him how many text messages are you likely to make? I know that wasn't any fun in listening to me explain that, but I want you to be aware that when we see these types of problems, they will often be worded similarly, and you'll notice that there is a rate of change and an initial cost. The initial cost being your y-intercept and your rate of change being your slope. And that's all for me. I look forward to talking to you guys soon. Take care, and I'll see you later.